We'll call them properties. So we're going to talk about certain properties that numbers have. Let's see. 8 plus 7. What is 8 plus 7 equal to? Uriah. I'm sorry. Student. 15. Very good. Let's see. What if I had 7 plus 8? What is that answer? 15. Yes. 15. Very good. Oh, 15 again. Very, very interesting. Now, a property we can get from this is, well, we'll get back to that later. What if I have this? 8 times 7. What do you get? 56. What if I did 7 times 8? What do you get? 56. Ooh, 56. The same answer. So what does that tell you? If you're adding a bunch of numbers, what can you say? So right here, order doesn't matter. Same thing here. Order doesn't matter. So you can add them left and right or multiply left and right. We call that the commutative property. That's exactly why it's called commuting, because you are moving. You can move these numbers around, and you're still going to get the same answer. It doesn't matter if you're multiplying or adding. The thing is, it can only be either a bunch of adding or a bunch of multiplying. I'm going to add this. You may have been taught this, and maybe some of you too in YouTube land or parents that are watching this, you might have been taught that you cannot subtract that way. You can't switch it around. That is false. The key thing is this. If I were to say 8 minus 7, you got to keep in mind that sign has to stay with that number. So this sign has to stay with that 7. That means you are only subtracting 7. This tells you not to subtract 8. It tells you to subtract 7. I can switch this around because that's a positive 8, isn't it? So I can switch these around to make it look like this. Minus 7 plus 8. These mean the same thing. So if we think about in terms of money, if I have $8, but I spend $7, how much money do I have? 1. I still have $1 left. If I owe somebody $7, but I have $8 in my pocket, I'm going to give that guy his $7 I owe him, right? And what am I going to end up with? 1. No. So the order, even with subtracting, it doesn't matter. But, and this is a big but, so pay attention. The key is that sign has to stick with that number. Got it? Why? Well, if I did it this way, 8 minus 7 means 1, right? Then if I had 7 take away 8, you can. You have $7, but you owe me $8. So you give me 7, but you still owe me $1. That's why lots of people are in debt right now, because they like to do this a lot. They have less money than they spend. So don't do this. So this is not the same as this. So the sign has to go with the number because that's how they were put together. 3 times 5 divided by 3. Now watch this. What's 3 times 5? 15. What's 15 divided by 3? 5. Now I'm going to rearrange it. 3 divided by 3 times 5. What's 3 divided by 3?
1.
1. What's 1 times 5? 5. So you can rearrange even division problems, but you have to remember that this dividing, you are only dividing by 3. You're not dividing by 5 because it says divide by 3. It doesn't say divide by 5. It doesn't say divide by 15. Just divide by 3. So I can move this in between these guys. 3 divided by 3 times 5. You can even do this side first. 5 divided by 3. Well, let's do it. Five divided by 3 is just 5 divided by 3, 1 2/3, which is just 5/3. 3 times 5/3, if I rewrite this here, bada boom, bada bing. 3 divided by 3 is 1, isn't it? If I can reduce that, and I'm left with a 5. Shazam. But the key idea is that you are always dividing by 3 because it says to divide by 3. You don't get to change it and say, I want to turn it into a divide by 15. If I had this, I want you to add this mentally. Oh. Add that mentally now.
49. 30. 40. It's 40.
I got 40 and 30. How'd you get 40? How'd you get 30? Well, who had you get 30, then 40?
3 plus 7 is 10.
So this is what you did. You grouped the numbers in a different way. So what you did was you looked at this and said you got a 3 and a 7. You added that together to get a 10. And then you took an 8 with the what? 2 to get a 10. Then you took the 11 and the 9 and you got a 20. So the answer is actually 40. But you got the right idea. How many of you guys did 8 plus 3 is 11? 11 plus 11 is 22. 22 plus 2 is 24. 24 plus 4 is 33. 33 plus 7 is 40. I mean, you could do it that way, but you don't need to. What you could do is look for numbers that you can add together quickly in your head and add those first. Why did you choose 7 and 3? Yeah, they end in a 0, and it's easy to add 0, isn't it? You just write a 0. You don't do anything. So pick numbers that are easy to add together. I'm going to give you another one, except we're going to deal with subtracting now. 18 plus 29 minus 8 minus 9. What is that answer? Yes?
30.
Yes. Yeah, the answer is 30. Doing it mentally, you could do the exact same thing with subtracting. So again, you can move subtracting around. That commutative property works with subtracting as well. Just realize you're subtracting 8 and subtracting 9. What would I want to subtract 9 from? Do I want to subtract it from here or here? Which would be better? Yeah, because here, that ends in a 9 and that ends in a 9. This and this, you could just say, oh, that's just 20. So that and that is a 20. I'll put that at positive 29. And then I could take 8 away from 18. What's 18 minus 8? 10. And what's 20 plus 10? 30. So we combine two rules or properties together. You can commute, move them around, and then associate. In this case, I associated 18 minus 8 plus 29 minus 9, and I grouped those guys together. So you can associate numbers. When it's adding or subtracting, you can do that. Same thing with multiplying and dividing. This is called the distributive property. When I was taught these properties, I was never given an application for it. I was like, okay, I know the properties, but I never used it for anything because no one ever taught me to use it for anything. So here's the distributive property, the traditional way that's taught. 2 times 5 plus 7. You can write that as 2 times 12, which is 24. Or you could do 5 plus 7, and then do 2 times 5 plus 2 times 7. 2 times 5 is 10. 2 times 7 is 14. 10 plus 14 is 24.
Whoa.
Pretty cool. But why would I need that? That's so much more work than doing that. Why don't I just add 5 plus 7? That's what I would do. This is the reason why. Comes to multiplying mentally. So if I were to do 2 times 157, in your head, you would break it up to be like this. 2 times 100 plus 50 plus 7. You just do that in your head. What's 2 times 100? 200. What's 2 times 50?
100.
What's 2 times 7?
14.
So your final answer is 314. Which was easier, this way? Ah, so in this case, this was easier to multiply. In this case, that's just dumb. Why would you do 2 times 5 and 2 times 7? If it was 57, sure. 2 times 50 is 100. 2 times 7 is 14. Your final answer is 114. You just multiplied quickly. So that is the distributive property and its application. If you too would like to be mental about math, please subscribe or watch this video. You might want to watch my last video over here. Please enjoy your day and keep it mathy. Add the music. Hey, what are you looking at?